Welcome to Notebook 21, LangChain Expression Language and Chains. In this notebook, you will learn about LangChain runnables and the ability to compose LangChain runnables into chains using LangChain Expression Language, or LCEL. By the time you complete this notebook, you'll understand LangChain runnables as units of work in LangChain. You'll intentionally use LLM instances and prompt templates as runnables. You'll create and use runnable output parsers, and you'll be able to compose runnables into LangChain chains using the LCEL pipe syntax. We'll begin by importing what's necessary for this notebook. You'll see, per usual, we will be importing the chat NVIDIA object. As we did in section 1 towards the end, we'll be importing the chat prompt template. And as a new import in this notebook, we're going to import the string output parser, which we'll discuss at more length as we start to use it further in the notebook. Let's create a model instance, just as we've been doing, using chat NVIDIA, passing in the base URL for our local LLM instance, and as we've been doing for the sake of consistency, setting the temperature explicitly to 0. And now let's discuss LangChain runnables. In the previous notebooks, you learned to create simple LangChain prompt templates, and furthermore, to instantiate them with specific values for their template placeholders with the invoke method. So as a kind of review here, we're creating a prompt template that consists of the string answer the following question, but then parameterizes the question that we would want to pass in to eventually send to the LLM. And we know that once we have a chat prompt template, that we can invoke that template. And when invoking that template, we provide the values for the parameterized values that we want to supply. In this situation, we specify that question should in fact be fulfilled with the string "in what city is NVIDIA World Headquarters." So you also know, right, that when sending a prompt to an LLM instance that we have created in LangChain, in our case with the LangChain component chat NVIDIA, that we also use the model instances invoke method, right? So if we take our prompt here and we do llm.invoke, you've done this many times already in section 1, then it comes as no surprise that we can get the response. In this case, we're popping the content field off of there, and we can see NVIDIA's world headquarters is located in Santa Clara, California, USA. Okay, so we've looked, or reviewed, I should say, the invoke method on a prompt template, and we've also reviewed the invoke method on an LLM instance. Now, the presence of the invoke method on both LLM instances and on prompt templates, in fact, is not coincidental. In fact, they are both LangChain runnables, which we've put in bold here to emphasize that this is a specific term in LangChain. In LangChain, a runnable is a unit of work that can be invoked, as we've just done with both the LLM instance and with the prompt template, but also they can be batched and streamed, as we've done with LLM instances. Runnables can also be transformed and composed, which we haven't looked at yet. So just to sanity check this hypothesis, right, both that prompt templates are a runnable and that runnables, in addition to being invoked, can be batched and streamed. Let's try to do some batching with our prompt template. So as you know, when we batch, we pass in a list of values. So here is a list of dictionaries where we're supplying a question property with 3 different questions. And now, instead of doing template.batch with a single question as we did above, or excuse me, template.invoke with a single question as we did above, we're going to try to run the batch method on this template. And if you look, just like when we do a batch on an LLM instance, passing in a list, we get a list back. And in this situation, from the prompt template, we get a list back of chat prompt values And if we kind of drill into each of these, into their content properties, we can see that in batch, each of these prompts has been created with the specific question that was passed in for one of the instances in our question collection. So just keep this in mind for now, and as we kind of explore a little bit further about runnables, it's going to make sense why we're spending so much time looking at that specific set of details about LLM instances and prompt templates being runnables, and also the ability to invoke and batch them and also stream them. So LangChain expression language is a declarative way to compose runnables into chains. A chain is a reusable composition of functionality. We chain runnables together through LCEL's pipe operator. And here's a literal of the pipe operator, which at a high level is going to pipe the output of one runnable as input into the next runnable. Now, many of you maybe have worked at the Unix command line, maybe on a Linux machine or on a Mac OS machine. And if you've spent a fair amount of time working at a Unix command line, then you're already going to be familiar with the pipe operator, right? Which in Unix land is a way to chain together the functionality of various programs, typically in service of a larger goal. So if you don't actually know what I'm talking about here, if you're not like a bash programmer, then don't worry too much about this. But for those of you who have worked at the command line, the Unix command line, significantly, I think it's helpful to kind of make this connection to help develop your intuition about how LangChain expression language pipe operator is very similar to what you would do at a Unix command line, say at a bash shell. So here we have a bash command. Just as a small note, in Jupyter, we can apply magic at the top of the cell using the double percentage point operator to specify that this cell, instead of being run as a Python cell, which is standard and default, we're going to run it as bash. So we're going to run the bash command echo hello pipes. We're going to pipe that into the rev command, which will reverse its input. And then we're going to pipe that into the tr or transform command, specifying that we want to take all lowercase alphabet letters and transform them to uppercase alphabet letters. And if we run that, you can see we get hello pipes reversed and uppercased. And you know, the point being, again, that if you're using the command line and you're familiar with this, you're going to kind of know what's going on. But even if you haven't, you can see we've got 3 different pieces of functionality that can be used separately or in conjunction in lots of different combinations. And using the pipe operator, it's a very concise and elegant way to chain together functionality for a given goal. In this case, something arbitrary to print a string, reverse it, and uppercase it, but you're starting to see the idea. And LCEL's pipe syntax operator is just as convenient and just as powerful, and we're going to start looking at it explicitly right now. So let's begin with a simple chain, kind of relevant to what we've already started doing in this notebook about, you know, sending a question to the large language model instance to be answered. Just to keep everything right in front of us, we're going to define here again our LLM instance, and we're going to define here again our prompt template, which again parameterizes a question and says answer the following question. So now we're going to create our first LCEL chain by composing these 2 runnables together. Remember, LLM instances are runnables, prompt templates are runnables, right? And all we have to do is take our template and pipe it into our LLM instance. It makes sense intuitively that we want to utilize the prompt template first, right? And then send the resulting prompt to the LLM. So in our pipe, obviously, we're going to put the template first. And when we create a pipe like this, when we create a chain like this, it returns a value that we can store in a variable. In this case, we're calling our variable chain. And now we've got this chain. So let's investigate it a little bit further. Chains in LangChain have a helper method, which is getGraph, that has a few different options. And what we can do here is we can use the getGraph draw ASCII output and print it which will give us a little bit of a visualization about what's going to happen in the chain. Now, this is a very straightforward chain, but already it's a little bit helpful, right? We're going to have a prompt input, which is going to go into a chat